I'd like to solve this formula for the variable n. And on formulas, you will typically see a bunch of different letters, and you sometimes use it in the form that it's given to you, and other times it's more handy to have it in terms of another variable. And so when I say solve for n, what I want to end up with is n equals, and then all the rest of the variables moved over to the right hand side, or the opposite, I can have it equals n like this, and all the rest of the variables on the left. The first thing I want to do to try to get n by itself is to clear the fractions. And to clear this fraction, it's a 2, and I do have an equal sign, which is important because that means I can multiply both sides by any number that I choose. And I choose to multiply by the 2 because I see that it will reduce away on the right hand side, and I'll just have a 2s on the left hand side. Now I have n times a quantity, and I want the n by itself, so I'll do the opposite of this multiply here, and I'll divide by that whole quantity because we know we can do that. And if I divide it on one side of the equal sign, I have to divide on the other. These reduce to 1, it's a form of 1, and I'm left with n equals, and n is on the right hand side here, and that's just fine, over a plus l. If I wanted to, I could also write it as n equals and put the rest of the variables on the right hand side. It's equivalent, and either form is as good as the other. Now I have another formula that I'd like to solve for the h, and I see I have an h here and I have an h there. Now that's different because on the last problem I only had a single h. So what I'd like to do is factor out this h. That's going to be my strategy here. So the variable I want to solve for is the h. So I'm going to factor it out like it's the greatest common factor. And I can see that it isn't the greatest common factor, but it is a common factor. So I can factor out the h, and what I have left is g minus 3g squared. And that's equal to w. Now I'm at the same position I was on the last problem. I have h times some quantity, so I want to divide both sides by that quantity. And then the g minus 3g squared is the same thing top and bottom, and I'm multiplying in between here, so I can reduce those two to 1, and I'm left with h equals w over g minus 3g squared. And here's one for you to try. So to solve this one, I'll use my same first step as before, clear fractions. And I'm going to do that even if I was solving for the v. I would still want to multiply both sides by the v to get rid of that fraction. And so then I have VP equals small n, capital R, capital T, and I am solving for the capital T. I see that I have multiplication in between both of these variables, so I can do the opposite of multiply, which is divide, and I'm going to divide by both variables, the n and the r, that I want to get rid of. And the n and the r both reduce, and I'm left with T equals VP over little n big R. Here's another one for you to try. I want to solve for the T2, which is here. I'll give you a minute. And when I come back to this, I want to solve for the T sub 2, so the same first step as always, clear fractions. So I'll multiply both sides by L, and I have LH equals Ka times the quantity T sub 1 minus T sub 2. Now these numbers here are called subscripts, and you say it as t sub 1 because t subscript 1 and t sub 2 for the subscript of 2. Now these are not the same variable even though they have the same letter. This subscript makes them unique. So they are not the same, so they cannot be combined in any way. Now I have this Ka being multiplied by the quantity t sub 1 minus t sub 2. I could distribute it if I wanted to, or because I know I'm trying to get the t sub 2 by itself, I may as well just divide both sides by the Ka, because then those Ka's are gone and I'm just left with the part in the parentheses. That's rather helpful. I have t sub 1 minus t sub 2, and that's equal to the LH over Ka. Now I want the t sub 2 by itself, and since this is addition or subtraction between the two and my t sub 1 is actually a positive t sub 1, I will subtract t sub 1 from both sides, and I'm left with negative t sub 2 equals, and these aren't like terms so I can't combine them. I just have to write them side by side. And then I was supposed to solve, here it says for t sub 2, not for negative t sub 2, so I'm not quite finished. I need to figure out how can I move this negative. And I've decided what I want to do is multiply both sides by a negative 1. And when I multiply the right hand side by a negative 1, I end up with just a t sub 2. And on the right hand side, if I go ahead and distribute the negative 1 inside the parentheses, I will have negative LH over Ka plus t sub 1. And I do definitely need to multiply both sides by that negative so that I can get a positive t sub 2 for my answer. Okay,